Okay, so hopefully at this point you've already watched our first video today. If you haven't, please go back and watch it. This isn't going to make a ton of sense unless you're introduced to the second fundamental theorem of calculus on the first video. Um, what we talked about really quick on your assignment tonight was that if you're taking the derivative of an integral, your lower boundary is a constant, your upper boundary is just x, you simply just plug in x to the original equation and then you're done. Okay, however, these are more complicated items where your lower boundary is a variable, your upper boundary is a variable, so you're going to have to use the second fundamental theorem of calculus, which is right here. Okay? So let's get to it. It says the derivative of the integral of t cubed plus 6t squared dt from x squared all the way to 2x. Okay, so just remember that this, if we're using, these symbols or this theorem up here, we're going to be using w to represent our upper boundary. We're going to be using v to represent our lower boundary. Okay, so to use this, we're going to say f of w. Okay, what that means is I'm going to take my function and I'm going to plug w in wherever I see t. Okay, so w is 2x. Okay, so instead of t to the third, I would write 2x to the third plus 6 times 2x squared, okay, that's my f of w, times w prime, which is the derivative. W prime means the derivative of your upper limit. So the derivative of 2x is just 2. Okay, now I'm here, minus f of v. So it means I take v, whatever that is, which is right here, and plug it in for t. So now I'm going to write, instead of t to the third, I'm going to write x squared to the third plus 6, instead of t squared, I'm going to write x squared squared. Okay, times v prime. So the derivative of v, the derivative of x squared is 2x. Okay, so just to recap, I took my 2x, plugged in wherever I saw t, and I took my x squared and plugged it in wherever I saw t, and I kept the exponents, I kept these exponents in the original function the way they are, 3 and 2, 3 and 2. Okay? So from this point on, it's all a matter of simplifying. We have our answer here. This is our answer. We just need to simplify it. Okay? So one thing you're going to have to remember is your exponent rules. Remember that if you have an exponent outside of two terms that are multiplied together, that exponent goes to both of these. Okay? So 2 to the third is 8, x to the third, plus, now this 2 goes to both of these. So 2 to the second is 4, times 6 is 24, x squared. And I'm multiplying all that by my w prime, which was 2. So I'm just going to leave it here for now. Minus, now we go to our next one. When you have an exponent of an exponent, power of a power, remember our rule for that, we multiply these together. Okay, power of a power, we multiply together. So x to the 6th plus 6x to the 4th, and now we're going to multiply all that by 2x. Okay, so just to keep going, I'm going to distribute this 2, so it's going to be 16 x to the third plus 48 x squared. Okay, minus, this is a 1, so now when we're multiplying 2x times x to the 6th, when we're multiplying the x's, we add our exponents. So this is going to be 2 x to the 7th. Okay, now minus so one thing I should have said here is we're distributing this minus sign. So this is a minus. This now becomes a minus because negative positive becomes a negative. So it's going to be minus 12x to the 5th. Okay? We are done. The only thing is rearrange this in proper order so that the exponents are descending. So we want to start with our highest exponent, which is negative 2x to the 7th. Let's go with minus 12x to the 5th. So take care of those two. Plus 16x to the 3rd. Plus 48x squared. Okay, this is your final answer. Okay, so let me just double check here, make sure I did this right. 12x to the 5th, 16. Yep, that looks good. Okay, so again, it's using this formula up here. This is your W, this is your V, and just following this formula up here. Okay, let's try one with a trig function. Okay, so same thing. We've got a lower boundary and an upper boundary who it's more complicated than just a constant and a variable. If it was just 0 and x or 1 and x or 3 and x or something, all I need to do is plug in the x right there and I'm done. Okay, but it's more complicated. We're taking the derivative of the integral from x squared to 2x of sine squared t dt. Okay, so in order to approach this, we need to use the second fundamental theorem of calculus, which says right here, we're going to take f of w. So if this is my w, this is my v, I'm going to say sine squared. Instead of t, I'm going to plug in my w, which is 2x, times w prime, which is the derivative of 2x, which is just 2. Okay, minus f of v, which means I take x squared and plug it in here. So sine squared, instead of t, I'd write x squared, times the derivative of v. The derivative of x squared is going to be 2x. Okay, so let me rewrite this. Let me just bring these out in front of the signs. So just to clean it up here, I'm going to say 2 sine squared 2x minus 2x sine squared x squared. Okay, let's see. Can't the sine squared 2x's and the sine squared x squared, can't do anything with that because these are different. This is a 2x, this is an x, so it's not like you can factor out a sign or anything like that. Remember, the 2x and the x are attached to the sign. But what you could probably do here is factor out a 2. Okay, just to simplify it, I could say 2 parentheses sine squared 2x minus x sine squared x squared would be, looks like my final answer. Okay, so this would be my final answer. Okay, I know this may have been a little confusing today. You know, go back and watch the videos if you need to. Look at my answer keys if you need to. Reach out to me if you need help. If you need it, just let me know.